So hi again. We have reached the following exercise. So it's called changing string. So we should consider the following declaration of a graph. So it's adjacency matrix since we have a here integer. So we have a starting string and an ending string and a set of strings. So we should find a path between the start string and the end string via the set of strings. So it's okay. We have multiple strings and we need to pass from one string to another, so they telling us that a path exists if we can get from start string to end string by changing only one character at a time. So when moving from one string to another, I can change just one character, and the string should be in the set. So here's an example. We have starting cog and end bad, and we have this set of strings, so we can pass from cog to bad by just changing one character. So I have placed all the words here. So, and we need to modelize this question into a graph. So what we can do is that strings are the vertices, and an edge exists if we can pass from one vertex to another vertex via a changing of one character. So for example, from bad I can go to cat, and vice versa. So I can go from cat to back since I'm just modifying one character here. I can go for example from cat to cat and cat to cat because I'm changing just the last character. From cat I can go to sat, I can go to rat, and stuff like that. Again, rat and sat, we have a connection between that. Con, we'll see that. So maybe here con, I cannot relate it neither with C and N or C and O or O and N. So it's alone here. Bag, I can link it with fag, fog with fag, and mostly that. So we need to do all that. So we'll make it. We'll do that in a while. So if I'm in a cog, where's cog here? So we didn't add cog, so we have cog. Let's add it here, cog. So in cog I can pass to cag, for example. I can pass to fog. So I need to pass from cog, and we need to add bad too. So bad, I can reach it from bag, and maybe just that. So if I'm start from cog to bad, so I can go from cog, fog, fag, bag, and bad. And there's other ways also: cog, cag, bag, and bad. So there are multiple solutions. So we just need to print not the shortest path, but just if we have a path from these two words. So how should we solve this question? So we need to traverse the graph. So either we'll use BFS or DFS. So it's very obvious that we will use BFS. So because we're trying to reach a node, and maybe it's not at the end of the graph, it's somewhere near, so it's better to use a BFS. So we'll be choosing the iterative, of course, because we will be using Q. So here is the implementation of the iterative BFS traversal using an adjacency matrix. So you can find the link of this page in the description below. So I'll copy the code and we'll use it for to solve the question. So I'll put it here. So let's increase first the number of edges or number of elements in the queue. Let's say we have 100. However, the question doesn't stipulate any information about that. So let's start. At first we have the adjacency matrix. So at here we will not be reading directly an adjacency matrix. However, we will be directly reading some strings, and we will just then adjust the adjacency matrix. So what I will do is that I will remove both these, and we'll see what we'll do. So maybe I will try to declare a graph in the BFS in the adjacency. So we'll see that in a while. So let's remove all this and let's start in the test. So in the test part, let's start by for example printing, enter the number of strings or words. So here I need an integer for the number since I need to read the words. So let's say it's called here the variable size. So we need a variable called int size. So here just for the word or number, and then we need to read those numbers and we need to store it in some structure. So since you have multiple words, so we need an array of strings. So what we will do is that we will declare it as a double pointer. We'll call it a set. So let's first reserve in the memory. So it's a double char and a malloc of, so size it's the number of words, multiple the size of char star, and so this is the array of pointers, and then we will loop. So we need an integer I for the loop. So for I from 0, I less than size, I plus plus, I need to read a string and then place it in the array. So to read a string I need a string, so let's call it str1 of n, and we need to read it. So let's say printf enter word number 1, so it's I plus 1, and then we'll read the string, so percentage s str1 without address, and then I need to allocate the size of the strings into the array set of I. So in set of I we'll do a malloc of char star. So I will copy this, and instead of size we'll do strlen of str1. So in order to use strlen I need to go up and check if there's string.h here. So I will include the library string.h in order to use the strlen function. So now I have reserved, I need to copy. So I cannot, for example, write this is completely wrong. So what I should do is to str copy to a set of I the string str1. So I have read all the words, and then I have placed it all in the array. I need now to check to read the starting vertex, the starting word and the ending word. So I need also here a second word, so I can reuse str1. I will use str2 just to read the starting string and the ending string. So printf enter starting and ending strings, and I will use scanf with 2%s, and I will read the first string and the second string. So how should we build the graph, the adjacency matrix? So we can, if you followed me in the exercise 2, so we will keep integers in the adjacency matrix, so it's not strings. So in order to launch the BFS, we need to find the index of these two strings str1 str2 in the array of set, which is called set. So again we need two indices, so the index of str1 in the set and the index of str2 in the set. So index str1 and I str2. So I need to loop. So I will loop again from I equal to 0 to size, and I will compare. So if strcmp of a set of I comma str1, so it's equal to 0, so we can say here not. So I will save I str1 is equal to I, else if not strcmp of set of I with str2, so if it's equal, I will save the index. So we have in I str1 the index of the first string and the index of the second string. So here we can call BFS. So I will call it, for example, a pass. I will change the name, pass exists, for example, and I will pass the set, so the array, its size, and the index of the first string and the index of the second string in the array of set. So if a pass exists, I will just print a pass exists, otherwise there is no pass. So pass doesn't exist. So this is for just the task. So let's just skim over it. So we have declared an array of strings. So we have read the number of words. We have the array of pointers to strings. We have read the size strings and place it in the array. So we have an array of strings here. Then we have read two strings, the starting and ending strings, and we have found in the set. So in the set, we have placed all the strings, the index of the str1 and the index of str2, and then we will launch the BFS in order to check if there's a path exists between the word pointed by str1, so the index of the word in str1 and in str2. So we have here BFS. So of course we will not suppose that we have multiple connected components. So if we have multiple connected components, it means that there is no path. So I don't want to reach two connected components. So we will not do that. We will not be using that. So of course, so let me first change the prototype. So we don't have a graph here. We have an array of string. So we have char st. Let's call it set again by st, and then we have the size. We have the index. So the index of the first string. Let's call it start, and the index of the ending string. So we will be using visited. Of course we will be using visited, so we need a queue. So let me copy this, since we will not be having connected components. It's not the purpose of the question. So, and here all the adjacency matrix we've already, so we need maybe a bit just to construct the adjacency matrix. So we will need visited. So first we need to declare a graph. So before that we need a graph. So again, it's a pointer, and in the graph we will do the allocation. So here it is. So we allocate a graph. After allocating, we need the set of vertices. So the set of vertices is equal to the number of strings, which is equal to size. The number of edges, so most probably, so it will be, so we don't know. Maybe the graph is dense, maybe it's not dense, and we know that if it's dense, if there's edges between all the vertices, it's equal to n multiple n minus 1 over 2. So in the worst case, however, we will not be using the value of e in what follows. So you could even not fill the element here, so because we don't know. So let's then, we have the array of visited, so it's equal to the number of edges here, edges, and then we need to allocate the adjacency matrix. So let's copy this. So we have the adjacency, which is equal to int double star. So we have an array, and then we loop over the set of vertices, and we allocate each element. So, and let's here directly place that all the elements for visited are equal to 0, since we usually do that in a special for loop. So we put it equal to 0, and then we will use also the second one here to place the adjacency matrix to 0. So we are doing the same work just in one directly loop. So we need here u, and we need v. So let me repeat. So for here we have created the graph. we have also allocated the visited array. So here the adjacency matrix is allocated, so here's just the array of pointers, and then for each element of the adjacency matrix we need to allocate an array, so it's the row, and we say that this vertex u is unvisited, and then we loop over each element of the array, which is a row here, and we place 0 to say that the adjacency matrix is now a 0. So how do we fill the, as we have said, the adjacency matrix? So we have said if we find that there's a difference between a word and another, so we can pass by changing just one character, so we can place an edge. So how can we find that? How can we say that two words can differ from just one character? So for that we will write a function that do the difference between two strings. If the difference, it means if the number of character that changes is just one, it means that we can move that. So we are here. So for that we need to write a function. So the function will return the number of differences in terms of characters in the string. So let's call it string difference. So it will take two strings, so char star s1, char star s2. So we have pointed over two strings, and we need to calculate the difference in terms of character. So if the character, so as long as s1, the reference s1, so the content is different than 0, what I will do is that I will check. So if the reference s1 is not equal to the reference s2, what should I do? I should increase the difference. Yes, and then I will return the difference. So I need also to increment the counters here in order to work. So either we can place it here s1 plus plus, s2 plus plus, or you can directly place it here, since plus plus is more stronger than s1 and it's post incrementation. So first we get the content of s1 and then we increment the pointer. So here it will return the number of differences. For example, here from CAC to COG, the number of different characters in each row is just one, just A and O. For example, the number of differences between bat and con is 3, because none of these characters are equal. So what I will do, I will loop over the adjacency matrix, and if there's a difference of 1, I will place 1 in the adjacency matrix. So I'll have two loops. So for u equal to 0 till size or arrow v. So from here I will be using v. So let's copy this. So of course I will not compare the same string. So I will not start from 0 here. I will start from u plus 1. So it's obvious, since I will not place one on the same string. So if the string difference is equal to 1, so string, let me copy it from above. So if the string difference between set of I and set of, not I, set of u and set of v, if it's equal to 1, it means that I can place 1 in the adjacency matrix. So here I can place 1, and since it's an indirect graph, so again I place it in VU. So this is the trick. And then so we need the queue, so I'll place the declaration up, and so here we have, so first we create a queue, so we enqueue the starting index. So because I will start from the starting index, I will say that visited is equal to 1. We can say that, and then we loop over the front, we dequeue. So we don't have here a print v, we don't have printing, we just need to check whether we have reached the ending element. So whenever we are in the queue and we reach, so if v equal to end, it means we have reached, so directly we return 1, we don't need to loop until the end of the queue. And then we will loop over w equals 0 Okay, we will loop, and if it's not visited and there's an adjacency, there's a link, so I will enqueue the element, and we'll say that this is equal to 1. So this is in principle. So let me repeat. So in the past, we have created the graph, we have filled the graph. So first, it's the adjacency matrix is equal to 0, and visited is equal to 0, and then we have looped over the set of strings, and we have checked if there's the difference is equal to 1. We have set 1 in the adjacency matrix, and then we have used the normal BFS. We have EQ, we have enqueued the first element, we have looped over the queue, and for each adjacent vertex. So since we have one here and we have worked on that, we will enqueue the elements and loop. So once we are in the queue and we found that the element is equal to 1, so we will do that. So I have prepared a set of example here. So we have 17 word. So we'll place it in one in a graph, and then we have one query which have may and pod. So can we pass from may to pod? So according to the example here, yes. So in may, for example, I can move to map. May, I can move to mad, it's better, mad, and then to pad, and then to pod. So we can pass like that. We don't need the pass, we just need to see if there's a pass or if there's not a pass. So let's see the errors. So there's a return one here, so we didn't return one, and okay, so if we finish, so we need to return 0. What else? Return void, so it should return one int because we are checking. Yes, we have if. What's more, we have a w, it's undeclared, it's at 132. So okay, we declare w. This is not just a counter. So at the end there should be a pass. So yes, there should be a pass. Let's say that I want to pass from let's pick two words from here. For example, may to sip. So there's a path. So because you have pip here, so let's say stock, one of the words. So pass doesn't exist, which obviously there is no passes. So this is for the exercise. If you have any difficulty, any questions, do not hesitate to write to me and will answer you back. And again, thanks for watching and stay safe.